Hey, Kim Jen.
Hey, Brito, what you got there?
Well, I heard you had some crazy chemistry experiments we could do.
Yeah, this is one of my all-time favorites, but it always makes me scared, so...
I'm not scared.
You're not scared? Well, we're safety up. We've got long pants, closed-toed shoes,
Safety
goggles,
matters.
long sleeves, but this is the reaction. This is lab-grade isopropyl alcohol, and we're going to take, this is the formula for isopropyl alcohol. We're going to take isopropyl alcohol. It's going to burn in the presence of oxygen.
How much are we using?
25 mils. I put a black mark on there for our aging eyes. And it's going to burn and produce carbon dioxide gas and water. And if you remember our styles of reactions, you'll remember that this is a straight up combustion reaction. Okay?
Straight up.
Straight up combustion reaction. Now, whenever you...
I'm pouring this in here.
Pour it in there. Okay, now, this has a very high vapor pressure, so you're going to roll, no, don't cover it. Safety first, you're going to roll it around. We're going to remove all the flammable stuff out of our work area. And you're going to keep doing that for 30 seconds. We got about 10 more seconds. And then you're going to dump the excess.
I don't think there's any excess.
There will be. Dump the excess into here.
Like I said, no excess.
Okay, now we're ready. All right, just in case, we're going to get this out of our work site.
Now, what? When you say we're ready, what are we doing?
We're going to light the tip of that. Move the rope.
There we go. It's all good. Watch out. Back up, Kim Jen. You ready?
I'm ready.
What on earth?
Brito!
Did you see the jet flame come out of that thing?
She blinded me with science!
I think what we need to do
We need to do this in the dark,
we
man.
need to do this at night. And you can't repeat this. If you feel this, feel this.
Oh my goodness, it's
This
smoking
gives
hot. It
off-
was a jet engine.
This gives off nearly 2,000 kilojoules per mole.
Hold
of
up, tell me on the science.
All right, so your isopropyl alcohol, it burned in excess oxygen, all out here, produced carbon dioxide and water. Now, in fact, let's get this chance to cool. See the liquid in there? Guess what that
Dude,
liquid is?
It's leftover alcohol, but there
No,
wasn't
it's
any.
not leftover alcohol.
Water?
Yes, it's water that condensed. So that's the water from the reaction. So we're actually going to measure that so we can do some math with that water. Let me get a...
See it? That's crazy.
So we just saw isopropyl alcohol burn in the presence of excess oxygen. And remember, when it burns in oxygen, it produces carbon dioxide and water and a whole lot of heat. It produced nearly 2,000 kilojoules per mole of isopropyl alcohol. And don't worry, guys, I'll do all the math with you later. So you've just seen one of my favorite experiments, the WHOOSH bottle, and we put isopropyl alcohol in there and we expected it to fill the whole 5-gallon bottle. Now, Siri told me that 5 gallons equals 18.93 liters. And since I don't want to find another R value, I'm going to go ahead and use my values in atmospheres, liters, moles, Kelvin, and that way I can use my 0.0821 R value. Okay, so because you understand, we could do this experiment in gallons and Fahrenheit, but then I'm going to have to look up another R value, and I really don't want to do that. So let's find out how many moles maximum of isopropyl alcohol it would take under the conditions that we were in Florida today to fill this bottle up. So we need to use the ideal gas law because we're talking about moles of a gas. And then I had to look up the pressure. Well, the pressure in Florida today was 1.007, so I'm just going to go with 1.0. The gallons, the 5 gallons is 18.93. The number of moles is what I'm solving for. Because I'm using atmospheres, I'm allowed to use this R value. That's the R value that goes with that, 0.0821. And my temperature outside was 84 degrees Fahrenheit, which is 302 Kelvin. So now what we're going to do is we're going to solve for N. So I'm going to pause for 5 seconds, and you go ahead and solve for N. All right, if you did this right, you should have gotten 0.763 moles of isopropyl alcohol will fill that up. Well, I don't know if I get a bottle of isopropyl alcohol, I don't know how many milliliters that is, but I know two things. I know that the molar mass of isopropyl alcohol is 60 grams, and I know that the density of isopropyl alcohol is 0.78 grams per mil. So now if I want to figure out how many milliliters of isopropyl alcohol it would take to vaporize and fill up my entire Whoosh bottle, I just need to do some good old dimensional analysis. So let's first of all go from moles to grams, and then we'll go from grams to mils. So our first step is we're going to go from moles to grams. And I know that I have 0.763 moles of isopropyl alcohol. And I told you that 1 mole of isopropyl alcohol is 60 grams. And if I multiply that out, I'm going to wait 5 seconds. You pause the video and do it. I get 45.8 grams of isopropyl alcohol. Now, most people, when they measure out a liquid, they don't measure its mass, they measure its milliliters. So now I need to go from grams to milliliters, and I'm going to use the density of isopropyl alcohol. I told you right here that the density of isopropyl alcohol is this. So here I go, step 2. I'm going to go from grams to mils using density as my conversion factor. So 45.8 grams of isopropyl alcohol. There's 0.78 grams per 1 mil. And so I'm going to say 45.8 divided by 0.78. I'm going to pause for 5 seconds. You pause the video and calculate that. And you should have gotten 58.7 mils. So folks, to fill up my Whoosh bottle or my 5-gallon water jug, it would take 58.7 mils of isopropyl alcohol. But I don't know if you noticed when I did it, I only put in 25 mils. I put in less than half of what it would take. The reason is I don't want the reaction to be so violent that this thing splits, because you can use this between 5 and 10 times, and then I have to get another one. So I only used half the mils. But the point is, do you see how you can use PV equals nRT to solve for a given amount for a given volume? And then once you do that, you can convert to grams, and you can use your density of the substance to convert to milliliters.
So I'm pretty excited.
Why are you so excited?
Because we did this in the daytime and it was exciting. I think it's going to be super cool now.
Yeah, it's much better. When I do it in a classroom, we always shut the blinds and turn the lights out.
You do crazy stuff like this in the classroom?
Yep, we do.
Oh man, that's awesome. I'm going to see if there's any excess. There's no excess.
All right. Here.
Don't do it yet.
All right, we ready?
Go for it, Kim Jen.
Okay, that was incredible.
That was very cool.
All right, so the reaction produces water. So let's see how many mils of water we got out of there. I'm going to dump it in here.
Wow, there's a lot of water in
Yeah, there is a lot of water. Now, a lot of it's probably vaporizing because this thing is stinking hot. Yeah. So the calculations say you should get out about 25 mils,
And that's like what that is, right? I think we're about 26 maybe. That's cool.
that's cool. Good job.
So how could
High five.
how could you calculate that? What was it based on?
The moles of the reaction, so I'll explain that later.
Cool.
We just saw me pour water out of the 5-gallon container after the reaction. So where did the water come from? Here's the reaction that we just did. Isopropyl alcohol, and if you remember, I put in 25 milliliters of isopropyl alcohol, and this is lab grade isopropyl alcohol. It's not the alcohol that you can just go buy at CVS. Well, actually you can't buy it right now because everybody is hoarding it. But anyway, the lab grade is close to 100% isopropyl alcohol. Now, in the presence of oxygen, now you see I've got a 9/2, and I told you don't ever have a fraction. I just did this so that this would be 1 mole. This would have a value of 1 in front of it. We could go through and multiply everything by 2. If we did that, this would be 2, 9, 6, 8. And that would be the equation correctly balanced. But we're going to leave it in this format for now, just to help with our calculations. Now, the theoretical value of water produced. Well, why am I so concerned about how much water produced? Well, I got a liquid at the end of the reaction. And according to this, it says it produces carbon dioxide and water. Now the water should be in the gas form, but if it gets trapped in there, it will condense when the bottle cools enough. And this appears to be what happened. So let's see if we can calculate the theoretical value of the water produced. So our first step is we want to find out how many moles of isopropyl alcohol we used in the reaction. Okay, now there's something else I need to remember. Isopropyl alcohol isn't like water. Water has a density of 1 gram per mil. Isopropyl alcohol has a density of 0.78 grams per mil. So I'm going to have to go from mils to grams to moles to find out how many moles of isopropyl alcohol were in my reaction. So no big deal. Dimensional analysis is our friend. Put down our given. I'm just going to call it iso so I don't keep writing isopropyl alcohol. Now I want to go from mils to grams. So if I have mils there, I put mils here to grams. This conversion factor right here is going to be my density. And my density is 0.78 grams per mil. So I'm going to put a 0.78 here per mil. Now you can see that I'm canceling mils and I'm left with grams. Now where do I want to go next? Next I want to go from grams of isopropyl alcohol to moles of isopropyl alcohol. And if I added up the molar mass of all of this right here, I would get approximately 60 grams. So there are 60 grams of isopropyl alcohol in 1 mole of isopropyl alcohol. So you do the math. I'll pause for 5 seconds. And 0.33. So in this reaction, I put in 0.33 moles of isopropyl alcohol. So let's go back to our reaction. So now I have something that I can compare with. I can say 0.33 moles put in How many moles of water should I get out? Well, if I look at my balanced reaction, I should get out 4 moles. So for every 1 mole of isopropyl alcohol I put in, I should get out 4 moles. So you can just simply multiply by 4 to find the moles and then convert to grams of water, or you can use dimensional analysis. I'm a big fan, obviously, of a dimensional analysis because it keeps me from getting confused. So I'm going to put down my 0.33 moles of isopropyl alcohol. And then I'm going to go 1 mole of isopropyl alcohol, according to my balanced reaction, is going to yield 4 moles of water. This, in our class, we call this our mole bridge. And what is it? It's the bridge between moles that we get from the balanced reaction. It's a conversion factor that works for that specific balanced reaction. And now I want to go from moles to gram. 1 mole of water is 18 grams of water. And when I multiply that all out, I get 23.76 mils of water. So when I did the reaction, I should have gotten approximately 24 mils of water. All right, we're trying this with a smaller bottle.
Whoa. Hold on, I got another one.
Yeah, it's gonna be